So, what's your name, man? Huh? Ryan? Nice to meet you, Ryan. I got a science question for you. If I shoot this up in the air, what makes it come down? Gravity! Excellent, man. Good answer. So I got another science question for you. We're going to do an experiment. If I drop the balloon and the ball at the same time, which one will hit the ground first? Ball. You're right, the ball hit. So why the ball? Almost. A lot of people think that, but gravity is affecting both things at the exact same way. So the reason the balloon falls slower is because the air is pushing back up on it. So if you were to do this on the moon, where there was no air, on the moon you would drop both at the same time, which one do you think would hit no air? It's actually a trick question. They both hit at the exact same time. There was actually an astronaut that tested it when they were on the moon. They dropped a hammer and a feather at the same time, and they both hit the ground at exactly the same time. It's pretty cool, huh? Did you know that on the moon there's a lot less gravity than here on Earth? Do you know how much less? Would you like to find out? I can show you how much you would pay on the moon. Check it out. Imagine how high you can jump if you only weighed 8 pounds. Pretty cool, huh? So when we go to the moon, we have to take into account the fact that it's a really big satellite. And when we launch from here, it's really, really heavy. But when we get to the moon, it's not as heavy. It weighs a lot less. So when we have to launch a second time, it'll launch differently. Pretty cool, huh?
So actually, you were both right with what you said before. Well, you said that the ball is going to hit first. You said that gravity pulls on everything the same. And you're both correct. Gravity does pull on everything the same. But the reason that the ball hit first is because when something's falling through the air pushes back up on it. So it's much easier for the air to go around the ball than it is for it to go around the balloon. So the balloon falls a little bit slower. If we were on the moon, though, and we dropped these, then the moon doesn't have any air. So, but it still has gravity. So on the moon, they were both land at the same time.
Cool, right?
So the X Prize this one is the Google Lunar X Prize. It's being sponsored by Google. The point of the competition is it's a worldwide competition for a private company to land a lander on the moon, and then it has to move 500 meters away to a new location. So at the first landing spot, it has to take a lot of pictures, video, transmit back to Earth, move, take more pictures, video, transmit back to Earth. Have you heard much about the other teams competing?
They're all private companies. I guess some people are from NASA that are founded at SpaceX. Is that included in that competition?
I believe SpaceX is competing, but it's that they're not NASA. The whole point of the X Prize is there's no government involvement.
Ah, okay.
It has to be all private companies. It's pretty exciting.
And is your test truly the actual, in the process of doing things? I assume a lot of it is within just the lab or within kind of paperwork. But where in your proposal are there tests?
Everything that we can possibly simulate beforehand we do. But of course, simulation never really works out. have like broken down, I guess, scale models of different things, and then over the summer we're going to try and build what's called a flat set. So it's a sort of one-dimensional architecture where we have, for example, just one of every system to make sure that each can talk to each other and iron out all the bugs in the communications. I think we're planning also to build like a smaller version of this to test and make sure we can get it up and out. But after that, I'm not sure.
All private companies. Our team is the only university one. We're competing against companies and entrepreneurs, people who can fund it themselves. But all 29 teams have no government